do some work. I'm going to try and push a very, very heavy block for a long time. For a really long time, I'm going to get really, really tired. Or I'm going to carry a very heavy object in my hand for hours and hours. And again, I'm going to get really, really tired and I feel like I'm doing a lot of work. Or I could just be standing here and feel extremely tired after some time. But if I was doing any of this work for a scientist, he wouldn't be willing to pay me. Because according to him, none of this is work. What? I get so tired, I can see the beads of sweat off my face. I know I'm working. How can he say it's not any work? Then, the question you would ask is then what is work? Well, what he would say then is that as long as what you do doesn't move anything, there won't be any work. So let's say if I try to push a heavy object and it starts to move. Or instead of just carrying something here and just keeping it there, I lift it up a particular height. Or instead of standing, I begin to walk. Then he would agree that I'm doing some work. So what is the difference exactly between the first and the second set of activities? First, I'm trying to push a block, it's not really moving. Case 2, I'm pushing it and it is moving. Second case, I'm carrying something, I'm just keeping it there for a really long time, but now I'm lifting it up a particular height. So in all these cases, what was different was that my force that I apply, in all these cases, right, I apply a force on the block. But as long as that force doesn't create a displacement, science doesn't call it work. So the first thing we want you to understand is that as long as you've been learning about English work in real life, I have been working, so where do you work? All these questions, in English, the word work is going to be very different from how we define work in physics. So the first thing we want you to do is do not equate them. Do not try to understand the work in physics based on what you know about work. Then, if the two works have nothing to do with each other, then why do we call them work? That's a question, right? It's a very fair question to have. Well, it is work in one way, for the fact that we don't want to introduce new words over and over again. So it's in a vague sense, it's work. But as far as physics is concerned, we need to define work in a very precise manner. So what we are doing here is trying to do that. So the first thing, doesn't matter how much force you apply, doesn't matter how long you apply it, as long as you don't create a displacement, it's not work. So now that you've answered what is not work, let's try and answer what is work. You need to have a force. The first requirement for work to be done is a force. The second thing, of course, is a displacement. And there, your textbook ends. But we're going to add a little piece to it. So you need a force, you need a displacement, and also you need that displacement to be in the direction of the force that you apply. So what does that mean? You have a force, you have a displacement, then some work will be done. But there could be cases where there is a force and a displacement, and there may not be any work done. Is that possible? Could there be a force and a displacement but no work done? So we will answer that question in a couple of minutes. So the first thing we need to do, answer the question, what is work? And what is work? As far as physics is concerned, it's the force multiplied by the displacement. So you take the force, you take the displacement, multiply the two, you get what is work done. But that is very imprecise. So we're going to take it one step further and we're going to tell you that it's the force in the direction of the displacement multiplied with the displacement. What do we mean by the force in the direction of the displacement? Could force be in any other direction? Yes, it could, right? Let's give you a simple example. When you're a kid, when you could do things like for no reason at all, you could be pulling a trolley across and just walking. Nobody asks you what you're doing. So you're pulling a trolley across, and how are you pulling the trolley? If this were the trolley, and if you're pulling like that, then the force you apply is like that. But does the trolley come flying towards you? It doesn't. It's moving on the ground. So the trolley is moving this way while the force is applied that way. In this case, if you multiply force into displacement, what you get is not the work done. Right? So what would you do? You would take the force in the direction of this motion. So some amount of this force is going to be applied in the direction of motion, some amount of it is not going to be applied, and we'll tell you which one it is. But right now what we want you to know, the definition of work done is force in the direction of displacement multiplied by displacement.